Okay, so let's say you're dividing polynomials, but they're giving you a question where it's a little different. Usually, we're used to dividing by just a simple, basic factor or an x minus 4, where there isn't a coefficient or there isn't a degree to the variable that you're dividing by. So let's say I give you an x squared plus 2, and you have x to the fourth minus 12x third plus 34x squared minus 24x plus 64. Okay, you will be presented with something with x squared, which basically means you want to look at this as if there is an x1 here. Like you want to look at this almost the idea that this is kind of like x squared plus that placeholder plus the 2. So what I like to do is say, okay, yeah, I want to eliminate this first term here. So let me work with the x squared. Let me work with the x squared here and say, okay, x squared times x squared, x to the fourth. That's going to help me eliminate this highest degree, or x to the fourth. But I have to use a place filler, so basically the x squared is getting multiplied by that 0, so you have a plus 0x3. So actually you have a placeholder in the divider at this point. And then x squared times the 2, that's a 2x squared. Don't forget, you're always subtracting, so actually you end up with a negative 12x to the third plus 32x squared. The 2 subtracted from the 34. And then I want to bring down the negative 24x. And again, try to eliminate this first term here. So what do I need to multiply x squared by to get basically a negative 12x? If I multiply negative 12x times the x squared, I want to match it up. I always want to kind of make it the same thing because I know I'm going to be changing the signs of everything here, so I try to match up to be the same, so if the sign changes, it ends up canceling out. And again, I'm doing the 12x times the 0x to give me a placeholder. These cancel out. This becomes a positive, this becomes a negative, this becomes a positive, and then I have a 32x squared plus a 0x. Basically, this is canceling out. And here's my 64. I like this 0x here because I know I'm going to have a placeholder, and I know I'm going to have a 0x to match up, so I'm already kind of taking a look here. Okay, this is going to work out to be evenly. Now I want to match up. Actually, I want to make this I want to make it the same, so I'll keep it positive, and then I'll have the 32x squared plus the 0x. 32 times 2 is 64, and then if I subtract these, this will cancel out. This was 0 anyway, and this will cancel out here. So my result to this would be x squared plus 2, which would be x squared minus 12x plus 32. And if I wanted to even work with zeros here and go a little bit further and say, okay, let me unfoil this to, I have a positive at the end but a negative in the middle, so I know my factors for 32 are 1, 2, 4, 8. I think there's a 16 in there. Yep, the 16, the 32. Basically being, okay, I know 4 and 8 would give me a 12, x minus 4, x minus 8. So I could say, some of my zeros could be, well, if I want to set this equal to 0, it could be, well, I can't have a result for this because there's no way to square a number and get a negative 2, but I can say that I can make this a 4, x of 4, 4 minus 4, 0. And then I could also use a positive 8, and this would be my 2 zeros here. Now you also might be presented with a problem where you have a coefficient in the front of a problem when you're dividing something like this. We're used to using synthetic division. It's a little bit easier and quicker because you don't have a coefficient in the front, so you could just evaluate the 3 and say, okay, let me use synthetic substitution using the -3. But here you actually, if you have a coefficient in the front here, you have to look to long division. At this point, there are ways of getting rid of this coefficient, but I think it just creates more work, and it's easier to just look at this and use the long division. So let's just look at that there. X squared, I want to get rid of this 2x, so I'll multiply by x squared to get to 2x to the third plus 3x squared. And then if I'm subtracting, this is going to give me cancel out. This will give me a 4x squared. And then I want to bring down the 2x. So if I want to get rid of this, I'm going to multiply by positive 2x, which would give me a 4x squared, plus, let's say 6x. Sign changes. This becomes a negative, this becomes a negative. This will cancel out. I'll end up with a negative 4x plus 9. And then I can multiply everything by -2. I could get the negative 4x minus 6. Signs change, this cancels out. Although in this case, a little bit different here, and I like the fact that I'm able to present the fact, okay, you did end up with a remainder, and when that happens, you just present the problem like a plus 15 over 2x plus 3, and the same that comes from the same thing. If I were to do 10 divided by 3, basically it goes in 3 times, and you have 1/3 left over. So basically you divide it by this, and you have 15 over 2x plus 3 left over. So that would be your remainder there.